Okay, on this video we are going to cover the homogeneous differential equations. Okay, now one important thing about these differential equations is how to recognize them. Okay, the name homogeneous is not because of the differential equations equal to 0, it's because of the following characteristic. Okay, let me tell you here. The power of this x is 2, the power of this y squared is 2, this one is 2, and this one is x and y. Each one has 1 and 1. If you combine the power, then it's going to be 2. As you can see here, all of them have the same power. So that is why the name homogeneous. Homogeneous degree. Why is important that characteristic? I will tell you later. But that is the one thing you have to recognize. Okay. About this example, don't care about the differential of x and the differential of y or the derivative. It doesn't matter the power there. But you have to pay attention to the power of the variable. So here the x is power 1. So this is 1. This is the power of this is 1. Okay. Now you can see here that x and y have power 2, but they have the square root. So in the end, all this expression is power 1, okay, because the square and the square root cancel. So this is homogeneous degree 1. Homogeneous degree 1, and this degree second. Second, then this will be first. Okay. Now on this example, you have to combine the x and the y power. So here I can see that the power is 3. Here I can see that the power is 3, and here is 2, and the y has 1. Then this is 3. So this is homogeneous degree third degree, or degree third. Okay, in that way you understand what is a differential equation. They have the same degree. Okay, what about that example? Here the power is 1. Here the power is 1. Don't pay attention to the derivatives. It doesn't matter the derivatives. But here the x is equal to 1 and the y is equal to 1. So it looks to be homogeneous, but here is not homogeneous. So this is degree 1. This is degree 1. But this combined is 4. So it's not homogeneous. So it's just another differential equation, but it is not homogeneous. Not homogeneous. Okay, so that is the property you have to pay attention. So what is the advantage of this property? Well, what happens here is that somebody discovered that any homogeneous could be first degree, second degree, third degree, any degree, as long as they have homogenized the power. Any homogeneous differential equation can be converted to variable separable differential equations. Because of that property, and because we already know how to solve variable separable differential equations, then we can solve it. But what is the conversion? Well, the conversion is like this. You have two types of conversion. W equal to y over x, or w equal to x over y. Okay, so that will be the variable change. Variable change. And how are you going to do the variable change? You are going to clear here the y is equal to w times x, and you are going to take the derivative with respect to x on both sides. So what happens here is that you will have the derivative of y with respect to x equal to, here you have a multiplication, so be careful here. It's going to be w derivative of x with respect to x is equal to 1 plus x derivative of w with respect to x. Alright, it's not the same variable. Derivative of w with respect to x, so it is leave it like that. So with this you are going to make the variable change, and with this you are going to do the variable change. Now the other method here is just the opposite. As you can see, here is y over x, and here is x over y. So here you are going to use this variable change when you have the derivative of y with respect to x. And here you are going to use when you have like this, x equal to w times y, and here in the opposite you are going to apply the derivative with respect to y. So here we apply respect to x, and here we are going to apply respect to y. Usually all the problems are solved with this variable change, but sometimes you have to apply this variable change, okay? So this is going to be the derivative of x respect to y equal to, here is going to be w times the derivative of y respect to y happens to be 1, w plus y derivative of w respect to y. And here are the two formulas that you are going to use. Again, usually is this the most common variable change. And why is most common? Because it's derivative of y respect to x. We are used to handle differential equations in this derivative of y respect to x, not derivative of x respect to y. But you can happen to use this sometimes. But what if you happen to have a differential equation that is not derivative of y respect to x? What if you happen to have indifferentials, which is this one? This one looks like the exact differential equation, but here isn't the differentials. So the only thing that you have to do is just to apply, well, multiply the differential of x. So here the differential of y is equal to w differential of x plus x differential of w. And this will be your variable change when you happen to have the differential equation in differentials. And here is just the same. You just multiply the differential of y. So differential of x is equal to w differential of y plus y differential of w. Alright? So engineers, this is how to identify it is a homogeneous differential equation, and this is the variable change. On the next video we are going to do an example on how to solve an homogeneous differential equations. Okay? See you in the next video.